Alright, alright, alright. Right, let me do that before we actually go. Yeah, you know the usual. Small delays setting up, you know. Schedule is more like a guideline, you know. Small delays, yeah. By the way, you know what I can do? Ta-da! Let me fix that real quick. Let's move that here. Glitch. At least I think it's gonna be a bit nicer here. Let me just try. Yeah. I don't know. Who cares? Let's just put it back up. All right. So. But by the way, is that one weird for you as well? because I'm kind of noticed that this is a bit weird. Anyway. Adapter array. Patched into the aircraft's data port, you discover weather forecasts of a massive tropical storm. Before you can figure out whether it will impact your vacation plans, however, your device suddenly turns off. Its battery is dead. You'll need to plug it in. There's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared, you make a list of all of the voltage adapters in your bag. Each of your voltage adapters is rated for a specific output voltage, your puzzle input. Any given adapter can take an input 1, 2 or 3 jolts lower than its rating and still produce its rated output voltage. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. If your adapter list were 3, 9 and 6, your device's built-in adapter would be rated for 12 jolts. Okay. Read the charging outlet near your seat as having an effective voltage rating of 0. Since you have some time to kill, you might as well test all your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in the bag at once, what is the distribution of voltage differences between the charging outlet, the adapters and your device? For example, suppose that in your bag you have adapters with the following voltage ratings. Some stuff. With these adapters, your device's built-in voltage adapter would be rated 22, 3 higher, because adapters can only connect to a source 1 to 3 jolts lower than its rating. In order to use every adapter, you'd need to choose them like this. The charging outlet has an effective rating of 0, so the only adapters that could connect to it directly would have a voltage rating of 1, 2 or 3. Of these, only one you have an adapter rated 1 jolt. From your 1 jolt adapter, the only choice is your 4 jolt rated adapter. From the 4 jolt, you can go 5, 6, or 7. However, in order to not skip any adapters, you have to pick the adapter rated 5 jolts. Similarly, the next choices would be 6 and then 7. The only adapter that works with the 7 jolt is the one rated 10. From 10, the choices are 11 and 12. Choose 11 and then 12. After 12, the only valid Adapter has a rating of 15, then 16, then 19. Finally, your device's built-in adapter is always 3 higher than the highest adapter, so its rating is 22. In this example, when using every adapter, there are 7 differences of 1 jolt and 5 of 3. Here's a larger example, okay. In this larger example, in a chain that uses all of the adapters, there are 22 differences of 1 and 10 of 3. Find a chain that uses all of your adapters to connect a charging outlet to your device's built-in character, and count the differences between the charging outlet, the adapters, and your devices. 1 is the number of 1 jolt differences multiplied by the number of 3 jolt differences. To begin with, get your puzzle input. We already did that, so let's get back to this. So we have this here, which is quite the list. From what I would reckon, I pretty much want to make a list. Wait, how again do I do a priority queue? Because effectively I want an ordered list, and I kind of wanted to just put it in. Well, I can just make a list and order it later, right? That shouldn't matter. For line in lines. Nums dot append int line. Let me just see if I can do... Can I do just nums sort? Yeah, so that's a thing. Let me just try this. Oh, well, so that's obviously not smart. Okay, let me just fix that here as well. Okay, so that does do it just fine. Yo, Zatanalyze, hey. Your Twitch phone doesn't show a notif. Maybe you have to... Yeah, it kinda is, that's true. Spoiler warning! So, you want to tell me I can just do this? Is that a thing? Well, int line it would have to be. So now I'll be excited to try it out, but... Oh, I can just directly do that here. Okay. I see. And then I probably... Can I just put that right after? Is that a thing? Let's see. None. Okay, so I cannot. Well, we tried. Okay, so that does work. So after this, we essentially need single steps, triple steps. There's always one because we have the last one, right? And here we would want to print single steps times triple steps. So what we now can do is essentially, we start at 0, so for Um, mm, it kind of might be tragedy forever, yes. Oh. Yeah, chill a bit, chill a bit. I'm just doing the bare bones stuff for now. Nah. Let's just do a helper. Let's just do a helper. So basically we just do yeah, 10.1 seems fairly straightforward. It's a bit tougher. Well, that kinda sucks. We'll see. So, and after that, we just need to ref equals num. And you did it on 4 hours sleep. Cool. Well, let's see. Let's see if that does work. Guess we'll find out. That is the right answer. You're 1 gold step closer to saving your vacation. Well, compared to the last one, the last stream's first assignment, this did start off a bit better. Part 2. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Every arrangement needs to connect the charging outlet to your device. The previous rules can still apply. The first example above supports the following arrangements. The charging outlet and your device's built-in adapter are shown in parentheses. Given the adapter from the first example, the total number of arrangements that connect the charging outlet to your device is 8. Oh, I see. The second example above has many arrangements. Well, you remember you brought so many adapters. There must be more than 1 trillion valid ways to arrange them. So surely there must be an efficient way to count the arrangement. What is the total number of distinct ways you can arrange the adapters to connect the charging outlet to your device. Oh god. That's a predicament. Yeah, the issue is I can't just factorize this because you say combinatorics, I said we didn't really have it. Well, let's think this through. So essentially the first way we can do this is just going this. The second way... Well, first off, let's do the usual. Can you prepend something? No. Is that a thing? I wonder. Let's find out. Well. Of course it wouldn't be, because obviously I need to... Maybe I need to do it like this? I don't know. Yeah, that is a calculation shot. Oh, so I can just do it. Okay. Because then we just add 0 here, so we have this. And once it's sorted, we can numstart append. Oh, it doesn't auto format, well. So and if we would print it again now, then we should have... Perfect. So that was the easy part. Now comes the hard one. So essentially, in this setup we could be skipping 1 totally, but we can't skip 2 because else 5 is kind of fucked. So I suppose if you leave that out, then you essentially have 2. So for every one we can leave out, we can increase. Oh god, this is annoying. Because obviously if I change something, then it changes it for all following iterations too if they change something again. I mean, could we in theory just count how many we could change and in the end factorize that? Huh. Okay, well, you weren't kidding by saying that this one is annoying. You did that with a dictionary, you say. Oh, not this part. Okay. Huh. I mean, essentially for every single one where I have the option to either do it or not do it, I could times 2 the entire thing. But that also doesn't quite work. Oh. God, that one is annoying. Was that the one where you said that people didn't do it? Was that the one? Wait, where's the leaderboards? Or was that the last one? Oh, stats. Oh no, it's 13. But 10 also had quite a few people who didn't care and dropped right after. Well, suppose it's bound to happen since difficulty's going up. I mean, technically, we could ignore every single triple step, because every triple step is finite. We can't change a triple. But if we have 2 singles back to back, we can leave one out. Well, as easy as the first one was, as hard the second one is. So, and what do they even want us to do? They want the total number. We can arrange the charging outlet to the device. So essentially, well, I think an index will do us a bit better. That has to be len. So essentially, since we start with 0, so that is indeed 0. I mean, that's an... I need to do this, right, if I want to include 0, because else it starts at 1, maybe? I don't know. Wait, we can't figure that out, though. Okay, so apparently it does start at 0. That's good, that's good. So we don't need that here. Let me just print I. Just to make sure. Okay, yeah, it does start at 0. That's good. That's very good. So now, essentially... Yeah, 0 lines of code has been written because, well, honestly, once I figure out how to do it, it shouldn't be hard. Music is a bit loud. I'm not sure if it's music in general or just this one track, because I figured it's a bit hard on the ears. Yeah, this one's quieter, so it was just mismatched. I need to fix that. You glance back down at your bag and regret life decisions. Alright, so technically, if hmm. I mean, if I have A2 was the assembler thing. This fun thingy. Oh, well, that's not it. So there's probably let's see. Alright, so I do think we are going to need factorial stuff for this. Now we can presumably do math.factorial and be happy. Oh, huh? But I did update it, didn't I? Oh, no, it's fine, it's fine. Okay, good, so that does work, good. I mean, essentially, couldn't I just, if I have something like this, I can do this in 1, 2, 3, 4 ways. Wait, does that make sense? 1, skip this, skip both. Yeah. Oh, but I can do the same here. Good luck. I mean, technically, every time I have a triple step, I can, let's call it, regroup my thingies. Because every single time I have a step of 3, I can't change it. So the only ones I have to consider are 2 and 1 steps. Just finished 10-1. Okay, this is a bit too loud. I mean, I can probably let's do split nums, or let's call it split sequences, which I'm gonna make into a list for now. So what we do here is and I think I tried this last time, so we'll just do this as well, which I think works. So I think you said I could just check with this if it's filled, right? So if there is something in it, then add it to split sequences. And then clear it. If that is not the case, so if it's already cleared, then ignore this and don't do anything, because we don't really care about it. Yeah, that's what I'm... Wait. But I can have 2 diff too, right? And if I have 2 diff, then I can only leave 1 out. Let me see. Maybe I don't have any either, but there might be. Yeah, I suppose there aren't any. Yeah, okay, well. But yeah, what I'm kinda... Oh, okay, yeah. Know what I've kinda been thinking? Like, if I have a distance like here, I can isolate this sequence and then calculate the factorial of that length, I suppose. Or maybe just write the function that does it for continuous sequences. And wait a second. Because essentially when I don't have a triple to a sequence, like here it's 5, right? So I could either skip this, I could skip this, I could skip this. I could just skip, I could skip both, I could skip both here. But I can't do more. Like, I could skip these two. So in total, it gives me the inner ones, right? So 1, 2, 3. Yeah, it gives me the inner ones factorial. That's the different assortments I get for these. So if I get these sequences, yeah, of course everyone has their own input. We wouldn't want anyone copying, right? For example here, this has to be contained, this has to be contained, so I have the option to either remove this or not. Which gets me, well, 2. Which is kinda weird, because 1 factorial is not 2. But for long, we should have 1 somewhere, right? Or maybe we don't. Oh, here we have 1 that's 4 long. For those that are 4 long, we have the options don't use that, don't use that, or don't use both. So we have not 2 factorial, because 2 factorial would be 2. But also not 3 factorial, fuck me. Is it just factorial plus 1? Well, let's see if that makes sense here. Because for this one, we have how many different ways? It's not factorial, yeah. That does make sense. But still, once I have them for every single subsequence, I can just multiply them together, and that should get me the correct result, I think. So I do want to try with splitting it for now. So, yeah, here we have this, and if it's not a triple, how did I call it here? A triple step, then I want you, or we can just say elif, not elif, else. Else I want you to just temp sequence dot append nums at I. Oh god, that song is so good. Xenoblade soundtrack in general is really, really good. Every single day in a different language. Nice. So what does this do for the first one? The first one does not have the case that the previous one is too big. So the first one would be added here, which is good. And then when we hit 2, which is where we do split, we still need to, if we have a temp sequence, append to the temp sequence the corresponding number, which we don't want to do if we have like 2 triple steps back to back, because in that case it's whatever. Like we really want to ignore these, because then we have a useless split sequence that's 1 long, which is kind of whatever. So I might still be missing something, but for now, I just want to try if this even does work. So let's just print split sequences for now, which we might actually need to. We still need to consider that this is not out of boundsing. We did it with PostgreSQL. Nice. And is he like saving his better languages for the later ones, or is he actually going full psychopath and doing the hardest the hardest assignments with completely new languages for him. Oh, okay, yeah. Good, good. So since we know the last one is a triple step, we can just say if you hit a triple step after appending the temporary sequence, if nums at I plus 1 is max of nums, then be done. Break. I could indeed, yeah. I could indeed. So let's see. Do you compile? Well, you do with a lot of empty arrays. Which probably means that this is not a hard copy. This just copies the reference, I suppose, huh? Because it does append something, it just doesn't append the stuff in it. Oh, copy, okay. Okay, so if... Now it's not fucked anymore, that is good. So it does, as intended, skip useless triple steps. Same in Java, by the way. Shut. So that looks promising. And since there's no step 2s, because it helps me understand what I want to do. Well, and also, now that I have this, I can probably just... now I can also do this. Okay, so this is a bit annoying because I... Okay, Steff, I'm gonna use this opportunity. Can you teach me how I do this switch case dictionary you told me about? Python switch case, because I just wanna learn this. Okay, so I just well, this is not Python. This is Python. Yeah, this is Python. Switcher. So you basically build a dictionary of functions which does stuff for you, huh? Okay, actually I might just do a switch. I might just do it with ifs. Switcheroo. Yeah, no, fuck this. I'm just doing lambdas. So we still need this here because I wanted to add something. So here we do, let's call it variations, which is 1. And now, this is the default one, like, yeah. Has to be 1, because there is 1 variation by default. So now, we can go into the first sequence, and if the sequence is... if the length of the sequence is 2, which is the minimum, then we don't do anything, so we can ignore that part. If it's 3, we get 1 variation, which we can do. So we can, in turn, double all our variations, because we, for every variation that comes after or before, we just added... Yeah, exactly, that's why I'm just doing ifs, because it doesn't feel like the effort to look this up is worth it. So now, if we have this, we gain 1 variation, so... variations times 2. Not plus, times 2, I said. So now if... I should be doing elifs, right? It looks a bit worse in my opinion, but it's faster, so... if it's 4 long, which... And this, of course, is still somewhat not optimal, but once I do it for like the first 5, because I think 5 is the longest we have, I might find a pattern, and after that it's gonna be easy. So if it's 4 long, we can either skip one or the other, or both. So we get a total of 4 variations. We can not change anything. We can skip one, we can skip both, or we can skip the others. So, in that case, we can do this times 4. Else, if we have a length of 5, we can, let's find one with 5. Why would you say plus? Oh, that's why you would say plus. So, and if that would come to 8, that would be pretty cool, because then we have a pattern. If it comes to 6, that would also be okay, because then we also have a pattern. So here we get... we can either keep it as it is, that gets us 1, we can skip the first, we can skip the second, we can skip the third, which brings us to 4, we can skip both of these, which gets us to 5, we can skip both of these, which gets us to 6, and we can skip this and this, which gets us to 7, and if I didn't miscount, that's weird, because, well, variations times 7. So it's always 1 plus I mean, do we have anyone with 6 in here? Wait, which doesn't even matter because I'll just think it out anyway. The song is not for your brain thinking. Oh, yeah. If it's too loud, I can make it quieter. So please do tell me. We can also just skip it. I don't mind. Yeah, now it's not too loud anyway. So for one that is 6 long, let me just. Oh, God. Well, let me just. Because I prefer the visual way. Let me just write it out here. So, for this one, how many variations do we have? We can either keep it as it is. We can skip 1. We can skip 2. We can skip 4. We can skip 5. So that's already 5 different things. We could also skip the first 2, the second 2, and the third 2, which gets us to 8. We could skip... Well, don't we just... We could also skip this and this one. This and this one. Which gets us to 10. And then we can skip... we can't skip 3. So that doesn't work. Yeah, so wait, is it 10? That one makes sense, right? Let's go again. Keep as it is. Skip either one of the 4. That's 5. So now we did all this where we either change nothing or 1. Then we can skip 2, for which we have 1, 2, 3, 4, 5, 6 different ways to do so. Like we can do da-dum, da-dum, da-dum. That should be factorial, right? Is it just... Wait. It's no, it's 2 over 4, right? God, it's been so long since I did this. Anyway, thinking out loud, there's 1, there's 2, there's 3. No, it isn't. I'm glad that you're here to tell me I'm dumb. So we have 3 options for the first one. We have for the second only 2, because else we would just be doing 1 again from the first. And for the third we have just 1 option, which finishes off all of the 2 option pieces, so we get a total of 6. I don't, but I want to figure out if there's a system behind it, so I want to think it through and maybe it gets obvious then. So yeah, I'm wasting time, but I don't care. Alright, and for skipping 3, that's not possible, so we're done here. So if that is the case, then we have variations times 11. So this does seem like it goes up by 2, then 3, then 4. And in case of... if we... to a famous number database. Okay, I'll look it up straight away. So, and just for completion's sake, if length is 2, then variations doesn't change, so times 1, because we can't change anything. So there is a pattern. Oh yes. Yes, same with 1, yeah. So for 1 there is an exception. Well, for 1 it might just be 0 factorial, because that is 1, right? Oh, cool. So, 1, 1, wait, what was it? It was 1, 1, 2, 4, 7, 11. One plus n minus 2 times n minus 1 divided by 2. That does look quite promising, does it not? 11 should be correct. I think, at least. Like if you check here, we get 5 by just mutating a single 1 or nothing. And then we can do either we leave those 2 out, we leave those 2 out, we leave those 2 out, which is 3. We can do the same for those 2 and those 2, which is 2. And we can do the same for these 2, which is, well, 1. So it's 6 plus 5, which makes 11. Heck, you know what? Let's count it through for Let's count it through for a 7 as well, because that should make it really obvious, right? So according to logic, that should be times 16. So let's find out. We can either change nothing, which, yeah. Or we can change 1, 2, 3, 4, 5, which gets me to 6 variations. Huh? What do you mean disregards jumps? Well, there is no jump 2, which is the catch. The is what makes it way easier, because if I had to... No. If it's not a jump 3, it has to be a jump 1. Like, if we go to my output, you can see that there is never a jump 2. So it's a godsend, because if there were jump 2s, it would get way more complicated. Anyway, so for the 2 we can skip either those 2, and now because we have more, we can also skip those 2 as well. But we can also choose not to. Oh god, that doesn't seem well. So for this we can do just these. We can do all of them skipping 1, we already did that. For skipping just 2, we can either skip those 2, we can skip those 2, we can skip those 2, or we can skip this. So we skip this, and then either 1, 2, 3, 4. So for 2 we have first to skip 4. Then we have to, well, obviously not skip this. Skip this, and 1, 2, 3. Then 2, then 1. Because at this point we have the option to either go with this or this, and at this point we don't. We just can do this one. Which makes 10. Which kinda is a predicament, because we should be higher than 10, right? Because we can also decide to skip these 2, and then these 2. We have the option to skip 4, and that's why 11 here is wrong, right? Because I didn't consider that option. Because I can also skip 1 here, then 2 here. So we can either skip 2, 2, which is one variation which cannot be changed. But we can also skip 2 here and then either 1 here or 1 here, which is 2 variations, and we can also do it for the other way around, which is also 2. These are cases where we skip 3 numbers. And then the ones where we just skip 2, we already did those. So that's 5, which gets us to 21. I don't think we can do more. But that also... well, that gets us to 21, that's an issue. That also begs the question that I should look at this again. So we also have the option to skip this and this, which I did not consider. So that's 1 more, and plus another 1. So instead of 7 we get to 13 here. Wouldn't that almost look like... oh, wait. So it's 1, 2, 3, 6, 8? That's a bit weird, isn't it? So I suppose we want to get back to the website. Yeah, I am. So we get here this, and we get here this. Well, that was not good. Whose negation is unimodal? Well, that looks kinda good, doesn't it? Is there also a different one? Euler transform. Well, 21 is wrong, you think? Well, we can look if there's... I do not appreciate that one, brother. We can look if... So there's also the Fibonacci sequence. Okay, which always uses the ones before it. Okay, okay. The Fibonacci series seems like something a CS guy might use, you think? But let's figure out why this was wrong then. Oh, because I can still skip this twice. So wait, we can skip this. Then we could also skip this and then this, which is one more. We can skip this, skip 2 here. Okay, so that does get us to 24, as you said. Whoops. Which 24 gets us to, as you wait, that did not work out. Gets us to the Fibonacci number, and is there a different? Not really. So the question is, the Fibonacci... Well, I have no idea why there is, but there shouldn't. There shouldn't be one. Oh, well, Steph, do you want to do the honors or should I? Oh, thank you. This time I saw it. This time I saw it. Maybe you downloaded the file wrong, bro. I am trying to figure out how to best calculate this. Is there a math? Fibonacci? So that would look like there is not an inbuilt function for it. Even use @cache. Okay, so so essentially I just import cache tools from func tools. Okay. Seems good, seems good. So wait a second, so we can define it for a length of 3 to always be 2 or something. Like I don't need to do this because 5 is the maximum, but let's see, what do we have here? Yeah, you are missing something here. That is the example by them. Those are already possible arrangements where they leave the 11 out from the top. The top one is the proper one, and those are arrangements that they have made. Those are all the arrangements that are possible. Because if you have 10, 11, 12, you can leave 11 out, but you also couldn't choose not to leave it out. That's not your input. That's what your output should be. Also, you get your output here, down here. Your input, if you don't have it yet. So, wait, so how did we calculate? Yeah, but what you highlighted is the output, not the input you should be using. The example is the top line. The arrangement with 0 changes is the top input. Wait, cache. How do I use this bad boy? Yeah, it is counted as different because it is. It's a different arrangement of the input 10, 11, 12. Both of them are a variation of that input. So, to come back to what we have here, if your sequence is 3 numbers long, you have 2 variations. You can either leave the middle one out or you don't. Those are the variations you have. Anyway, we want to, well, let me be lazy. Generate a recursive one. Oh god, that's using yield. Oh boy. So yield creates a list output. Or how do I see that right? Anyway, we kinda want exactly what this is, right? So we can go here and define this here. Well, no, I think I did that wrong last time. I want to define it before it. So here we could just say no yield. No, we're not using the yield because I only need the recursive one. What that guy had was a function that generates it in a range, which is useless here. Also, why is this name? Yeah, I thought Python would be like this, wouldn't it? I thought Python naming was like that. Well, anyway, we're using this one now. What was it? Control. I'm off by 1. Let's see. If we hand this a length of 2, then that might be actually right. If we give it a length of 1, it returns 1, which is wrong because well, it's not wrong, but a subsequence of the length 2 should return. So we need to do sequence minus 1, I think. Just print me the variations as well, man. Well, we don't need this anyway, so. I mean, I'm down to try. If it doesn't work, we can still debug it later. Too low. Well, maybe it was actually correct, huh? Let's think that through again. If we could give this dude 3. Well, if we have the length of 3, then this thingy would return to me 3, which is wrong, because 3 only has a variation of 1. But if we give this bad boy the input of 2, then it's correct, because we can vary it. Well, we have 2 ways to split up 2, which is fine. If we get it fit 4, we would parse in 3, which has, according to this, 3 different ways to be placed, which is correct. If we give it 5, which should be 7, then we get 2 plus whatever 3 was, which should have been 3. 2 plus 3 plus whatever 4 was. Wait. If we give it 4, we pass in 3. If we give it 5, we pass in 4, which gives us 3, which is once again 3. It gives us 2, which is, well, 2. And it gives us 1, which is 1, so we get to 6, which doesn't make sense. Wait. Because, wait, this is 4 long, so we have 1, 2, 3, 4. 4 ways to do this. So if we give it in 4, we should get back. Oh my. You know what? I'm done. I'll just do it. I'll just do this for now. Let's go with this for the time being. Let's see if this is a different result. Well, okay, yeah, sure. That is a higher result, so something was wrong in what we did anyway. That is the right answer. Well, so I didn't quite manage to get the formula, but It's something, I guess. That's the right answer. You're 1 gold step closer to saving your occasion. You have completed day 10. So, time for day 11. The Tribonacci is wrong, yeah, I figured. Yep. It does, it definitely does. I mean, what we could be doing is we can def trib and now we can just say if n equal. Did I just somehow code run it? Well, was not my intention, I'm sorry. So we can just say if n is 2, then I want it to, well... Let's look it up again. So you start with 2 zeros and a 1. So for 1 it's 1, for 2 it's 2, for 3 it's 4. And we're essentially shifted by 1, which we have to consider, right? Yeah, start transitions are wrong, yeah. I think we said that 1 was also 1, so if it's this or this, which is kind of tilting me because it should be this way around, return 1, then if n equals 3, return 2, else return trib of n minus 1 plus trib of n minus 2 plus trib of n minus 3. Now we should be able to just say, like if I give this 3 now, it returns me 2. If I give it 4, it returns me 2 plus 1 plus 1, which is 4. If I give it 5, it returns me 4 plus 2 plus 1. So that should be correct now, and now we can just strip off length of sequence. And also that isn't that kinda shorter than what I copied earlier. Anyway, if that is correct now, which it of course is not. But now it did it not save? Huh? Wait, why do I still have this? Huh? No, that doesn't look like it has to be in Oh, don't worry, I was kinda confused about what to do. My degree is for nothing, no! Degrees mean nothing. Why is that not doing the thing, though? Huh. I'm a tad confused. So does length of sequence for some reason always give me... Well, we can easily fix this if we just print length of sequence. Well, the print command wouldn't be too bad to do, right? So I'm at this point fairly certain that this is correct. Yeah, so so I'm also down to print the result of whatever this is. So okay, for some reason this is always a 1. Because if I call it with 3 then it gives me 0 and that fucks it up maybe? Huh? No, wait. Why should it be plus? My friend, if I do plus here, that's gonna not do shit. But that's 23. Oh. Is that it? Maybe? Yeah. Yeah, okay. Well, but I did read that somewhere. That is a thing. I think at least I read somewhere that this worked. Anyway, now we did it the fancy way, which is good. Anyway, that's 10. Easy. Okay, actually that's not it because yeah, I'm doing that. That seems smart. Only one, yeah, but we learned something, so that's worth for me. As long as I learn something, I don't care if I take longer. Good. Alright, time to read. Seating system. Day 11. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early nobody else has even arrived yet. By modeling the process people use to choose or abandon their seats in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input. The seat layout fits neatly onto a grid. Each position is either floor, an empty seat, or an occupied seat. For example, the initial seat layout may look like this. Good. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. The following rules are applied to every seat simultaneously. If a seat is empty, there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat's state does not change. Floor never changes, seats don't move, and nobody sits on the floor. After one round of these rules, every seat in the example layout becomes occupied. After a second round, the seats with 4 or more occupied adjacent seats become empty again. Okay. This process continues for 3 more rounds. Oh god! Oh god, that sounds like fun. Yay! Yeah, sure. Let's do that with NumPy arrays. It sounds like fun. At least it's gonna be better than me doing it with dicts of dicts and you tilting away. So we want to open 11 sspot.txt. Same here. Also, I forgot one thing at 10. We want to uncomment this one again, right? Alright, so let's begin with import. Import numpy as mp, which works perfectly, as it always does. First off, let's see at I don't need view anymore. Okay, so wait. Oh, it is quite big. Okay. I assume you can probably just instantly input that in a NumPy array, huh? Array. Aha! You would use NumPy to read the data, so that causes the question, how? Because like if I were to do this with normal dicts of dicts, I just essentially for each line make a line and then dict array, and then for each letter in the line you do like an entry, right? which we can probably do with for line. For I line in enumerate lines. And then we can do for j dot letter in enumerate line. And now, however I do my numpy array, then I could just say, like, you know, numpy, whoops. Right? I could fill it like this, presumably. And if I then go ahead and say, if I say I want to print this, then it fucks up because you probably call it some other way. Which we can do like this, right? So that does need an input. Well, let's see. So numpy empty, and I would assume that we need to len of lines and len of lines at position, I guess 0. It doesn't matter because it's always the same. And if we do that now, cannot interpret 97 as a data type. What? Oh, so we need to do this like this because else it doesn't realize that it's a tuple. Huh? A numpy array has to be floats. What? No. Just so you know. So I still have to map this to numbers, essentially, is what you're saying. Well, easy enough. In that case, we can just say if the letter is an L, then it's a seed. A seed should be, I suppose, 1. The number for a jar. But I wouldn't necessarily want to just get the number of the jar, because then I get numbers of with 2 digits, which kinda sucks, right? If there's a dot, then I want it to also let me rename this to NR. Is that also a thing, by the way? Can I do this? Lol. Yes, well, very nice. Let's just go with this then. So let's also add here data type int, which should remove the stupid dots, right? Yeah, it does. Good. So for some reason, oh, it just doesn't actually print the whole thing. Can I specify somewhere that I want to see everything? It's too large, yeah. That kind of sucks though, because it doesn't really let me check if my thing actually works. Okay, good. So it does work. Amazing. So now this is more for later. If letter is a hashtag, we want numarray to we want it to be I suppose we can give it 9. Which for now doesn't change anything. Yet, not yet! Planning ahead! Or so he would like to say. Yeah. But it also said that when we have this, once it's occupied, it turns into a hashtag. Yay. Not in that loop. That is indeed true, but I might just copy paste this later like a lazy fuck, and then I'll be very glad to have done this. But yeah, sure, we can remove it for now. Alright, so that gets us the numpy array, which is great. And what was the rule? Like, if a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. No occupied seats. Okay. Oh, and wait, whoops. We want to count how many iterations we need. Oh no, we need to do this as long as there is change. So we can, I presume, do another one of these. Done, true by default. God damn it. True by default, that's it. While done, iterate through the numpy array. So please do stop me if I mess this up. Does enumerate return me both x and y in the array, or does it not? NumPy and denumerate. Okay. Oops. Denumerate. Oh, and index gives me a tuple, but I can also, from what I think I learned, use the tuple like this. So now we just need to apply the rules. So if v equals 1, do I have to do this? Okay, well, okay, well, if that is 1, then it's a seed, and then you just have to check if it's not occupied. So is there an easy way to check the surroundings with this magic? Let's see, what can I do with you? From what it looks like, nothing. I just want to check if it's surrounded by occupied seats. I could slice. How do I slice? Get my piece of the cake. The cake. Okay, I do not slice here, but maybe I do slice here. No, I do not slice here either. Aha. Oh, I see. So that gives me a range here from like -1, 0, and 1. I actually was about to ask if I should be doing something like that, but I would have hard-coded it. So. Like I would have done the in thingy you taught me. So now I would just check if whatever value we do, like in our case I think we said 9, if 9 in this, an occupied array. Oh, just with booleans, okay. Let's call it occ. Occupied. So can you explain me what the zero is like? Well, I can just read here. Oh, is that so? Okay, yeah, good. That does make sense. So I don't. Yeah, I was kinda worried about that actually. And So that gives me essentially a zero initialized array. So now we can just say if any of these is 1 in occupied with the same thing, then if not 1 in occupied, so if none of them are occupied yet, then we want to, well, occupied. So occupied NP zeros. Oh, but then I would have to specify it again, right? That's essentially how what I did here, right? MPI xy equals 1 and oh, cool. So the one thing I wanted to ask from a bit ago, how does Python do with out of bounds? Because right now, if in the very first one it's gonna die here, right? Is there an easy way for me to just either catch it or ignore it? Because in the input it ignores them, right? I think you did say that Python loops, right? So I do need to check here. So I would have to check here if x not 0 or x not len of the nar dot width? Is that no? Height? No. Length? Dimensions? No. Help! Oh man, he says. I mean, one thing, is that endlessly looping or is it not? No, it can't be, because if it was, then this would not stay occupied. So you want me to say is not max of nar, but wouldn't. The fuck? Okay. Well. That, Mr. Steff, is why you're in the master and I am not. Or it might be. at least partially. nr.shape. Okay, so bro, how the heck would I have known that though? How the heck would I have known that? And then he hits me, you can just easy, bro. Yo, how the hell would I know that? Oops, that was one too much. Wait. Shape isn't a thing, right? Does it somehow not recognize my array as a numpy array? Huh? Oh, this returns an empty. Does this also return an empty? Well, that would at least explain why it's always not giving me any intelligence thingies, but still. Never seen empty in my life. No, okay, so how would I then okay, well, we just do zeros. Which does not change this, so that's quite good. But that removes need for this line. Less lines, park. So why does this return a tuple and this one not? Because that still means that this is an any, and I don't like this being an any, because I like my intelligence. Well, could do shape 1 for the y's. Yes, I not only could, but I also should. Okay, well, so at least that fixes the corner cases, right? So now what we have to check, if it's a seat and not a single one is occupied. I mean, this doubles quite nicely because it also checks if the seat itself is occupied, so that is quite good. So in any other case, it's X not in Y. What? Oh, well. It's X not in Y, not X in Y. Alright, so this checks if anything surrounded is already occupied. But we could also, which I should do before, if occupied at XY, does Python work with truthy values? So if I say occupied XY and it's 1, then it counts as truthy, and if it's 0, it counts as falsy. Is that only a JavaScript thingy, or does Python have that too? I mean, else I can just is 1. Don't think so. Okay, well then we're just wanting it. So now, if it is occupied, we want to check everything not none is true. That's an issue. So we want to count Technically we can just copy paste this one. -1 because we don't count the middle one is bigger than... Oh, 0 is indeed false, nice. Because that saves us some stuff. So we can do this in 1. I think it was it 4 or 5? 4 or more, so it's more than 4. It indeed doesn't, yeah. Wait, why is count not defined now? Okay, so I mean, I know that any is a thing, right? We know that this, yeah, count is not their function. So if that is the case, then occupied is no more. And then here we can drop an elif. Yeah, I want to, if 4 of the possible A tier match the condition, then I want to not have it occupied. Which is why I would have liked you to tell me how to sum it up easier. So it does work, okay. Nope. Oh, I see what you want. So I can't do that, and it just sums it up for this. Okay. Because this is an this is an iterable, and thus we can sum over it. Okay. So that essentially makes, if in that 3x3 grid we have more than 5, because we're subtracting the middle, then we release the seat, and otherwise we do this. One thing which I think I have to do is this. We need to use a second occupied. So we can do a temp occ, which is mp0's like, whoops, underscore like. And we need to write this one. And at the end of this, once we've iterated through it once, we want to occupied equals number arrays work by reference, by the way. So, I mean, you did quite indeed tell me that they were per reference, but what exactly does that mean for me? Because I think this is still correct what I did, right? Alright, so we still need to hit the exit condition, which would be simply if occupied then oh, okay. So that just means if all of them are the same. But I can also... So what I would want to do is if any are different, then make it false. And at the start we set done to true again. So... and after that you can copy. What do we want to print at the end? How many seats are occupied? So once this is done, we essentially just want to go through the occupied array and count how many ones we have, which, from what you've told me, is as simple as doing sum occupied, and that should be it. Is that correct? Well, if it's not terminating, then the truth value of an array with more than one element is ambiguous. Use any or all. A dot any. A dot any? They want to tell me that I should be using occupied dot any. Like I think they want me to do this. But that's not what I kind of want to do. Heck, why am I even bothering with this? I can just... if this ever happens... done equals false. And if this ever happens, done equals false. I don't have to bother with this. So if this takes a bit too long... Oh, was that the one you said that takes like 15 seconds? No? Well, then we might have an endless loop. I repeat, we might have an endless loop. It should be instant, well. Then it would seem that we have an endless loop. You have at least one error. Well, you told me how to fix it twice. Dot copy. Oh, that's what the reference one was. Okay. That still looks like we didn't fix it. So. might be slow, he says. Well, but it still shouldn't take this long, right? Yeah. Well, so it is. It is running an endless loop. I'm fairly certain about that one. The question is where. So we do done equals false while not done continue. Well, I can. Yeah, mine definitely takes longer. Like, that's definitely too long, I think. Hey, always glad to have you, Saturn. Let's see, what here could be fucked up? You did it with fancy convolutions. I mean, this should probably be occupied.shape, not nar. But I don't think this is the issue. Okay, let me, not here. Let me for each iteration print the sum of occupied. So we get to see if there is anything changing. What? Unexpected. Oh, wait, because. Yeah, okay. So it's always 0. That is weird. Huh. I mean, I'm not quite sure why print of sum occupied is even doing that to begin with, because that makes me feel that this is not working. Oh, that's stupid. Well, at least you found it. So I suppose that some does something different than I thought it did. Return the sum of a start value plus an iterable of numbers. Oh. Like this. Well, that at least does something, but it always returns me 0, so that's not that much better. So that is weird, because I do think that it should... Well, so here it tells me, we can already stop. Here it tells me it fills like all of them, which is good. It should be doing that. I mean, okay, look, instead of this, how about we do... Let's just do this for now. So you finish. It just, despite saying it would be filling here, oh yeah, sure, we can. That is weird. Equals equal. Oh, but you didn't see it just as long. You didn't see it just as long. We're both idiots. We're both idiots. Okay, well. Yeah, but I didn't write it. Didn't we have just the same issue on the operations one, right? I think we had that one before. I would never make such a fundamental error. Let's see if this terminates. How about it? I am... Did finish. I mean, let's just try this. I don't think it's gonna be correct because I have no idea what I just did. I totally knew that would be correct. That's the right answer. Easy peasy, dude. Easy. Before we read this, let's clean up the code. Yeah, it's so slow because of the prints. Yes. Also, this we no longer need, and this we no longer need. Let's see how fast this runs now. Oh, still takes 3.5, so that's not that much better. I'd really be interested to see your code here, by the way. Oh, well, the fuck? The fuck is this? Oh, that's from the prior one. Oops. Anyway, easy. Easy peasy lemon squeeze. Imagine if we fix the dumb mistakes, it's very easy. Alright, next one. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seeds, they care about the first seed they can see in each of these 8 directions. Now, instead of considering just 8 immediate adjacent seeds, consider the first seed in each of these 8 directions. For example, the empty seed below would see 8 occupied seeds. The leftmost seed below will only see 1 empty seed, but cannot see any of the occupied ones. So this one would see 8 occupied seeds. Okay. The leftmost empty seed below would only see 1 empty seed, but cannot see any of the occupied ones. The empty seed below would see no occupied seeds. What? Oh, it wouldn't see because it can only see in the directions, okay. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more. The other rules still apply. Wait, so... Please tell me he recaps that again. Wait, so what is the new rule? Instead of just considering the 8 adjacent seats, consider the first seat in each of these directions. Okay. It should technically not be that different. Code send, this one takes a few seconds to run, but you could speed it up easily. Let's see. .2 takes a while, well fuck. Imperial 0's like, 1's like, okay. What is Convolve 2D, bro? I'm gonna need some knowledge here. It is a convolution, haha.